All right, today we're going to cover topic 8.5, the areas between curves. This time it's going to be with respect to y. And my class asked me to begin today with a joke of the day. So your joke of the day today is, what do you call a belt made of watches? A total waste of time. Okay, let's move on. The area between two functions of y, instead of top minus bottom, is right minus left. Okay? Instead of top minus bottom, if I am flipping this thing with respect to y, notice something. This thing is sideways. I am finding this area in here. So instead of top minus bottom, it's right minus left. The main thing, it's the same process as topic 8.4, top minus bottom, but we have to know which one's on the right, which one's on the left. So let's get to some examples here. Let's find the area of the region that should have said bounded by the curves y equals x minus 1 and x equals 1/2 y squared minus 3. Let's make a little mental note. Anytime I see something like this, anytime I see an x equals some kind of y squared something, we are thinking of some kind of sideways parabola like that. All right? And so all of our transformation rules still applied. This is still a parabola, and it's still shifted 3 units, but this time instead of going down 3, it's left 3, like you see here in this graph. All right, so it's intersecting. It's got a vertex over here at -3. All right, so what we do with this one is we solve it for x instead of y. So I take my y equals x minus 1, and I add 1 to both sides. And I have that x equals y plus 1. Now I have both of my functions in terms of y. So if we're doing right minus left, the right function is the linear. So I'm going to have y plus 1 minus the left function. Make sure you put it in parentheses, 1/2 y squared minus 3. What about the limits of integration? Well, they didn't give them to us. They often don't. So if I'm going to find the limits of integration, I need to set the two functions equal to each other in terms of y. So I'm going to set y plus 1 equal to 1/2 y squared minus 3. Now, if it were me, I'd multiply everything by 2 right now. Just get rid of fractions. All right, so you have 2y plus 2 equals y squared minus 6. That's what I would do. And then get everything on one side. So I have that 0 equals y squared minus 2y minus 8. That's a very basic quadratic. Factors into y minus 4 and y plus 2. So my two limits of integration, notice their y values this time are 4 and -2. So I'm going to integrate this thing from -2 to 4. All right. Setup is the most important thing on this, so I'm not going to finish this problem. That should be a very straightforward problem to finish. Let's go on to the next problem. Let R be the region in the first quadrant bounded by the x-axis and the graphs of y equals the natural log of x and y equals 4 minus x. Find the area of R. Now, we could, I suppose, do this with respect to x and split this thing in half, but it's much easier with respect to y, okay? And if we do it with respect to y, this one is my right, and my natural log is my left, all right? So let's clean this up a little bit. Y equals 4 minus x. If I solve this thing for x, algebraically, be careful with this stuff, x plus y equals 4, so x equals 4 minus y, all right? And how would I solve y equals the natural log of x for x? Well, we've done this when in Unit 7 when we did differential equations. I would exponentiate both sides. E to the y equals e to the natural log of x. So my x value is e to the y. All right? And so now I know what my right and my left are. I have the integral of 4 minus y minus e to the y dy. And by the way, I guess I should have told you at the beginning of this, this is a calculator problem, all right? Because I need to answer the question, I need to get my limits of integration, all right? My bottom y value is 0, so that's the bottom limit of integration, but I need this one, all right? And we can do that with the TI-84. So we need to set those two functions equal to each other. Set y equals, and we need the y coordinate of that thing, all right? So as I plug this in, y equals 4 minus x. Notice I've got to do this in regular solved for y form, natural log of x, because that's the only way the graphing calculator will let me do it. All right, we will go to Zoom 6. I need to do an intersection. Enter, enter, enter. This number is the one I need. I need the y coordinate, not the x coordinate. All right, so I need the y coordinate of that point of intersection. All right, that's very important. So my top limit of integration is this 1.073, and then I can again use Math 9 on the TI-84 to get my answer here. Should be 1.79. All right, if you check that out. All right, multiple choice question. This one's, let's just pay attention here, see what's going on. We've got two curves. They're both solved for x on us. Which expression represents the area bounded by the curves? All right, well, notice something. They do not give me the limits of integration, so I'm going to need to set these two equal to each other. 1/4 y squared plus y plus 1, I'm going to need to set that equal to 2y plus 4 and solve this thing. Now, doing the algebra, which we don't need to do everything for that, we get, if I get everything on one side, I have y squared minus 4y minus 12 equals 0. All right, that factors into y minus 6 times y plus 2. So my two y coordinates are 6 and negative 2. All right, so that narrows it down to either this one or this one. But now I need to do the right function minus the left. I need to do 2y plus 4. Remember, we're doing the integral from -2 to 6 of the right function minus the left function, which is 1/4 y squared plus y plus 1. All right? And the rest of it is just some algebra. 2y plus 4, distribute my negative through. And we get -1/4 y squared plus y plus 3. So our answer is B in that situation. All right, let's take a look at one more problem before we wrap up. Let R and S, we talked a little bit about this one yesterday, be the regions in the first quadrant shown in the figure above. The region R is bounded by the x-axis and 2 minus x cubed and tangent of x. All right, so it's actually easier with respect to y to find this little area in here. All right, so what I have to do, though, is I have to solve this one for x. So I'm going to have add x cubed. So that leads me to x cubed equals 2 minus y. So x equals the cube root of 2 minus y. Solving this one for x means that x is equal to the arctangent of y. Take the inverse tangent of it. All right, if I take the inverse tangent of both sides, remember, if I do the arctangent of the tangent, all right, of x, I just get x. So if we take the arctangent of both sides, we get it. All right, so my right function is going to be the 2 minus y to the 1/3 power. My left function is going to be the arctangent of y. All right, and then my limits of integration, I need the y value here. Remember, the y value, not the x value. I'm going to tell you what it is from the graphing calculator by doing an intersection. It's 1.266. All right, and my bottom limit of integration is 0 because my bottom line here is the line y equals 0. And so this right here is my expression that I would use in the graphing calculator. One thing that's important, it's okay to plug it in on the graphing calculator and do it with respect to x. It will give you the correct value if you do it that way. Because, as you know, most of the things on the TI-84 are with respect to x. When you do this, you get an answer of 0.729. Let's go ahead and do that one on the graphing calculator just so you see what I'm talking about. We're going to do Math 9 from 0 to 1.266 of, in parentheses, 2 minus, now notice I'm using an x because that's my only option on the graphing calculator, to the 1/3 power and I need to subtract the arctangent of x. Dx. Double check what we've got there. Looks pretty good. And there's our answer of 0.729. And we will stop there for today on topic 8.5.